It's a great pleasure for me to introduce you to ESM-Tools. So ESM-Tools is a software to make Earth system modeling easy, efficient, and unified. So we believe that better software is essential for better science. ESM-Tools is built around this idea. But unfortunately, many scientists end up with the situation on the right. So basically, there's a code, but no author, no support, no documentation. It is not version controlled, unfortunately. So all of these things decrease the efficiency of the scientist and even cause undetectable errors. The solution is having a reliable system that is well maintained. So my talk consists of 4 main sections. First part, I will talk about the ESM-Tools, the motivation behind it. Then I will talk about the components and the supported systems. Then I will briefly mention about how we developed the ESM-Tools. And finally, I will tell you about how to get started and the user support. So ESM-Tools is a software package to perform common operations in the Earth system modeling. So those common operations are downloading, configuring, compiling, and running the models on different HPC systems. Those models can be atmospheric models, ocean, biogeochemistry, sea ice, hydrology, solid earth, you name it. They can be standalone or coupled systems. Our main goal is removing the technical burden so that there is more time for science. For this reason, we provide a common infrastructure. So this infrastructure uses the models. Basically, these are the software, the hardware, the HPC environment, and the operations. For example, setting up your run directory, the directory structure, having a consistent setup, setting up and running your model experiments. So what does ESM-Tools do? Basically, just as I said, it is a unified infrastructure. So everything is in one place. You don't need to know about the technical details of the underlying HPC system. So even unexperienced people can use ESM-Tools very easily. We provide YAML-based, easy to read and write conference scripts. So you write your run scripts in the YAML format. You will run your simulations as easy as possible, and this is actually the main motivation. As you run simulations, you can make online monitoring with the log mechanism. ESM-Tools will organize the file and folder structure for you. So the input directories, forcing the boundary conditions, outputs, executables, you name it. You don't need to copy anything back and forth. And as I said, it's only one interface. No matter if you use an atmospheric model or an ocean model, you will have one single interface to organize all of your work. Now, there are some misconceptions that it is not a new model, and or it's not a new programming language or a domain-specific language, although it resembles one. And we don't change your model code, and also we don't change the build process. Neither we change the license of the codes. It's only an interface over the models, so that models can be run very easily. So who would like to use ESM-Tools and why? First of all, our target audience is the Earth system modelers who are working on HPC systems. As we all know, Earth system modeling is a very complicated topic because those are complex softwares. They require a great technical knowledge. They usually run on the HPC systems, which are quite complicated compared to a PC. So the build mechanism is quite difficult. One setup that works may not work on a different HPC system because it may require a different configuration. So that you may need to require consult to the HPC documentation, or they may use different batch systems. Setting up and running are also quite difficult because they require complex configurations. Couplings are difficult. They require and generate so many input and output files. We need a consistent directory structure. And for automatization, you need to write scripts to automate the process. And the reproducibility is also a very important thing. You may make a run, but when you want to repeat that, you may fail if you do everything manually. So having said that, I would just like to summarize the old workflow and the new ESM-Tools based workflow. So I don't know if you also use this workflow on the right, but sorry, on the left, but so many people still do it like this. Basically, the model source code is hosted on a web page, not on a repository. So you just download this tarball model code. You just unzip it. You make configure and make, and probably it will fail because maybe the default configuration may not fit your HPC system. So you need to spend a lot of time to configure and compile your system. And once you get your executables, now you are ready to go. But it's still only the beginning. You need to prepare a lot of data folders like inputs and outputs and boundary conditions. You have to provide your name list, your run scripts. Then you submit your job to the HPC system. And probably if you do coupled runs, you may need to resubmit them for iterative coupling. Then when the runs finish, you have to move them back to the storage disk. Then you post-process the results. Of course, this set of operations are quite tedious to do manually, so many people rely on shell scripts for the automatization. But with the ESM tools, what we do is that you only call the command ESM master, and suppose that you would like to run ABCM, which is the couple of ECAM and phazon. Basically, all you do is that you say ESM-Tools install. So install is basically get, configure, and build operations. It's a shortcut. Then you give the model name. Here it is the ABCM, then the version. So this just clones the repository to your hard disk and just builds executables on the supported HPC system. Then you provide your run script, which is based on the YAML format. We already provide the samples in your repository. Then before you run your script with the ESM run scripts command, it is a good idea to check your run to see if it would run successfully. So basically, ESM run scripts check if you have missed anything. Maybe there are some missing boundary condition files, so that you don't crash when you just submit the job. Then you check your log, and hopefully it is fine. There are no errors, and you can basically run your model. So you basically omit the -C option there, and everything is fine. Then you can post-process the results with the ESM-Viz tool, which is currently under progress. So this is just to illustrate what it looks like in real life. On the left-hand side, you see one of the shell scripts that we developed at AVI. As you can see, it's quite already complicated and hard to read. It's very easy to make mistakes in this shell script-based automatization scripts. And on the right-hand side, you see a YAML file for the ESM tools. Basically, it's a run script, and with only using this script, you can run the ABCM. And I don't even need to explain that because the variable names are self-explanatory. So, and this interface is exactly the same for no matter which model you are using. So let me briefly talk about the components of the ESM tools. I won't go into the details of each different section, but the main idea is that the whole system is based around the ESM tools repository. So when you clone and install the ESM tools in the center, basically you will also install the surrounding packages into your default Python library install path. We have already seen the ESM master and the run script, and there are so many other packages. For example, you can very easily upgrade the system by using the ESM version checker. You can write Python-based plugins, and you can add them to the system by using the plugin manager. You can save your actions in the ESM database, and so on and so forth. So who uses ESM tools, and what do we support? On the left-hand side, you see a table. So in the components, you see the standalone models and the coupling systems. And on the left part of the table, you see the coupled systems. For example, you see ABCM, which is basically a couple of the ECAM and phazon. So if you want, you can run the models as standalone, or you can very easily run a coupled simulations. And from the user's perspective, there is no single difference between running a coupled system or a standalone system. Basically, you give the a very similar run script, and then you are good to go. On the right-hand side, you see a map of Germany. So this is the main developers and the users of the ESM tools. Currently, we have users in Germany, but we are looking very much forward to having international users, hopefully after this conference. So ESM-Tools is basically developed at Bremerhaven AVI and also at Potsdam AVI. I'm in the Potsdam branch. We are working together with many colleagues all around Germany, and we are integrating more HPC supercomputers and models. So to summarize, why you should use ESM-Tools. So I separated this slide to two parts, one from the user perspective and one from the developer's perspective. For the users, it is very, very easy to read and write because it uses the YAML syntax. We provide some default run scripts, so you don't need to start from scratch. The system is well maintained. We host it on GitHub. And whenever you have some issues, for example, you can raise an issue and we will take care of it as soon as possible. We update the system quite regularly. We do bug fixes. The system is very portable and it's very well tested. We run automated tests. And probably the most important feature is that we have a very good documentation based on Sphinx and read docs. And we also provide workshops. From the developer side, it's written in Python, so many people's favorite programming language. We actually started with shell scripts in the earlier versions, but when things get a bit complicated, we had to change from shell to Python because Python supports object orientation. It has many high-level data structures, so it is much easier to organize your program. It is very easy to debug, which is essential for the developers. You can use the Python debugger for that purpose. There are many configuration files. So when you want to run a model, there are so many default configuration files. It's kind of like an inheritance. And the user provides run script actually overrides everything. So it's a great architecture, I would say. It is hosted on GitHub, and we provide a robust branching model for good development practices. And we also encourage open source development. And what is currently in progress is that we try to incorporate more DevOps, CI/CD, and automated tests into our system. So from our perspective, how do we develop ESM-Tools? Well, I'm a part of the core development team, and together with that, we have external developers, as you can see on the German map I showed a few slides ago. So we are over 30 people.
You have 2 minutes left.
Okay, I will briefly sum up.
Sorry.
So basically, when you get the tools, you will be in the release branch, which is the supported and the latest one. And for each developer, they work in their own development branches, and we merge them quite often, so that there won't be any merge conflicts. And whenever a user issues a bug, we urgently make a hotfix and we merge back to the release branch, so that everyone is happy and there are no more bugs. So just to wrap up, our goals for the future is that we would like to have more users and more HPC systems. It's a call out for the attendees. If you are interested, please contact us. We would like to support more models, and currently we are working on more features such as online monitoring, online visualization, a graphical user interface, and more CI/CD. And with that said, we have already made a publication on GMD. You can find the preprints. And so this is the final slide to sum up. You can reach us over multiple channels, but I highly recommend you to start with the read the docs documentation. There you will find anything that you are interested in, and it's a very nice documentation. Step by step, it will get you started for the system. You can also see some bit outdated tutorials on YouTube. We will update them. You can sign up for a monthly newsletter, and you can also see us on our webpage. And with that said, thank you very much for your attention, and I'm ready for the questions.